Hi Rockridge, this is Mrs. Berger, and today we are going to talk about division with radicals. So up to this point you've added and subtracted, you've simplified things with radicals. Now we'll see what happens when we have radicals in the denominator. There's a few different things that happen. Now this is the lesson that comes after your quiz day. So for this day you may have only been able to get through the quiz with your teacher, and so this may be the end of day 3 for you, or it might be the beginning of day 4. But either way, this is a discussion of division with radicals. So just like how we did this with imaginaries, we're not allowed to have these radicals in the bottom. Just like we weren't allowed to have imaginary numbers in the bottom, nor can we have radicals in the bottom. That's not proper form. And so we will need to rationalize the denominator. So of course, rationalizing the denominator means making the denominator a rational number. Okay, making the denominator a rational number. And we saw how that happened with imaginaries, but we're going to go ahead and see how that happens with radicals today. Why do we do it? It's proper form to make sure that we have real numbers, rational numbers in the denominator. So if you come across something like this, 12 divided by the square root of 5a, this is a problem. We cannot have we cannot have radicals in the denominator. So for this one, we will counteract this problem simply by saying, well, if we were to multiply this by the square root of 5a, we would get on the bottom the square root of 25a squared. That's what we learned in multiplication, right? We learned that when you multiply two radicals together, you multiply the insides times the insides. So 25a squared. And then that will turn into the square root of 25 is 5. And the square root of a squared is a. The square root of a squared is a. So this is a nice, pretty, rational denominator, which is what we were after. Now don't forget, whatever we do to the bottom, we have to do to the top, because we have to make sure that we're multiplying by a version of 1. Otherwise, we're changing the chemical makeup of this, okay? So make sure that you multiply by a version of 1. Whatever you do to the bottom, go ahead and victimize the top by that, right? So make the 12 a victim of what you had to do. Always look and see if there's something to simplify up here. It doesn't look like there is. There's really nothing I can do about 5a. There's nothing to break out and put in front. So my work here is done. I have 12 times the square root of 5a over 5a. There's nothing to be done with this 12 and 5. There's no other a to cancel out. So I am finished. Okay, and I have rationalized my denominator. So you'll often have to multiply by the same thing, the square root of the same thing. Sometimes, though, you'll be presented with something that you don't need to do that much work for, okay? So when you come across something like number 2, the square root of 8 over 9, you can certainly do what we did before. You can certainly multiply, since this is the same thing as the square root of 8 over the square root of 9. You can certainly multiply by the square root of 9, but remember, what is the square root of 9? The square root of 9 is actually a perfect square. It's just 3, okay? So having 3 as a simplified version of the square root of 9 is super helpful. It doesn't mean that we have to multiply by the square root of anything to make that happen. And so we have already rationalized this denominator. So at this point, we just finish out the problem. My denominator is rational. Now there's something sitting inside this 8 that can be pulled out. We know that 8 can be broken into 4 and 2. So I'm going to take the square root of 4 and put it on the outside and leave behind the 2. That's the most simplified version of the numerator, and my denominator is 3. So that was just a lesson in check to see if there's some other way to rationalize your denominator that's the easy way, okay? Don't do more work than you have to. Now, number 3. Remember that the radical part is the only thing we really have a problem with, okay? The 5 is not the problem here. It's the square root of 6 that's the problem. So there's a couple ways you can approach this one as well. The square root of 6 can be fixed by multiplying by the square root of 6. You could also look at and carry the 15 and the 5 all the way through the problem. But you can also see that the 15 and the 5 can be reduced immediately. Either way is fine. If you reduce the 15 and the 5 as your first step or as one of your last steps, that's fine as long as it gets done. But to save paper, I'm going to go ahead and do that now. So I'm going to take care of this 15 and this 5 and reduce that fraction down to 3 over 1. So that I'm simply dealing with a 3 times the square root of 2 over the square root of 6. Now still, this is this pesky square root of 6. He's still causing problems for me. So to make him stop causing problems for me, I'm going to multiply by the square root of 6, which will result in the square root of 36 on the bottom. And of course, the square root of 36 is 6. So I've rationalized my denominator. Now let me go back through and do the same thing to the top. Remember, outside times outside, that's 3. Inside times inside, that's the square root of 12. Now in my next step, I'm going to pull out, I know I can break 12 into 4 and 3. So I'm going to take the square root of 4 and multiply it by the 3 that's sitting there, and leave behind the 3 that's inside that 12 that can't be square rooted. And then my final step, I notice that I've got a 3 times 2, which is 6, over a 6. So I'm going to cross those out and turn those into 1 over 1. So my most simplified version is the square root of 3. Okay. Now, if you're someone who already can tell that you could have reduced this square root of 2/6 into the square root of 1 over 3, that's certainly fine. You can certainly work on that as well. We're going to get into that in a couple of problems, but if you did that before you worked through it with me here on the video, as long as you end up with the square root of 3 as your answer, you did things correctly. Now, these are super tricky. These number 4 and number 5, these are super tricky. Notice you've got the cube root of 4, which is a radical in the denominator, which is the big no-no, and we're going to take care of that. So we can't take the cube root of 4, that's nothing pretty. We can't do it the easy way. And if we multiply by the cube root of 4 times the cube root of 4, we'll have the cube root of 16. And the cube root of 16 isn't anything helpful at all. We need to get this 4 to be raised up to something that is helpful. We need to get that 4 raised up to something that is a perfect cube. And the easiest way to do that is if I multiply by 4 by 2, I will get the cube root of 8. And since I memorized all those really helpful tables from the first lesson, I know that the cube root of 8 is a nice, clean, pretty 2. Okay? So these are super tricky. I don't just get to multiply cube root of 4 by cube root of 4. It doesn't work that way with these. I need to make sure that I multiply this 4 up to something that's a perfect cube. Once I get that worked out, I can go back and just victimize the top by whatever that was, right? So the cube root of 2 is now being multiplied by 2, so that becomes 2 times the cube root of 2 on the top. There's nothing to break out of this 2, so there's nothing more I can do there, but I'll carry that over, and then I'll notice that I can reduce that fraction. I can reduce that to 1 over 1. So now I'm just left with the cube root of 2 as my final answer. Okay. And then to demonstrate this skill again, we can break this into the cube root of 5 over the cube root of 2. The cube root of 5 is not a problem. It's in the numerator. I don't care what's going on up there. That can be just a giant, disgusting mess up there. That's fine. It's this root in the bottom that I'm having trouble with. So cube root of 2. If I was to multiply by another cube root of 2, I'd get the cube root of 4, which isn't anything clean and rational. So I've got to figure out how can I bump that 2 up to something that's helpful. How can I bump that 2 up to something that's a perfect cube? And if I take 2 and multiply it by 4, once again, I will get the cube root of 8, which is nice and clean and pretty, 2. So once I've worked that out for myself, I'll go back and do the same thing to the top. If I multiply cube root of 5 times cube root of 4, I will get cube root of 20. I'll check inside here and see if there's any perfect cubes. 20 can be broken into 4 and 5. 4 can be broken into 2 and 2. So 2, 2, and 5 are at the bottom of this factor tree. None of that is helpful. There's no groups of 3, anything in there. So we'll just leave that cube root of 20 as the nasty mess on top. And that's fine. We can have messes on the top, just not in the denominator. And I may not reduce this. There is no crossing this 20 out for a 10 and crossing the 2 out for a 1. You can't cross the streams, okay? This is outside of a radical. This is inside of a radical. There is no simplifying there. So this is the end of that. So now let's talk about the other thing we worked on imaginary numbers, those things called conjugates, right? Conjugates are same binomial Just an opposite sign on that second term. Remember that? Opposite sign on the second term. So that's what we have here. The conjugate of 2 plus the square root of 3 is 2 minus the square root of 3. And let's watch what happens when we multiply conjugates by each other. It's this magical thing that it happened with the i's as well. It's going to happen again with these square roots. So let's do first times first, outer times outer, inner times inner, and last times last. Just like what happened with the i's, those two middle terms will cancel. And I will be left with 4 minus, the square root of 9 is 3, so 4 minus 3, and I'm left with 1. So that's nice and rational. So this is super useful if we're trying to rationalize a denominator that's a binomial with a radical in it. I'm going to make use of this conjugate concept and go ahead and rationalize that denominator with the conjugate. I'm going to do a couple of these. I don't want to do all of them for you. I do want to leave some of this practice for you on your own. So I'll get through a few of these and then leave the rest for you to practice and check with the key, okay? So if we look at this, once again, we don't care what's going on the top. That's not our problem. It's the bottom that's the problem. I'm going to multiply by the conjugate of the bottom, which in this case is 1 minus the square root of 2. Whatever I do to the bottom, I'm going to do to the top, so 1 minus the square root of 2. Now, I've got two sets of foiling to do. So be careful. Take your time. First times first, outer times outer, minus 2 square root of 2. Inner times inner, plus the square root of 3. And last times last, minus the square root of 6. That's the top. The bottom, first times first, outer times outer, inner times inner, and last times last. I can cross some things out, which is my very favorite thing to do in math class. Negative square root of 2, positive square root of 2, those go away. I look at the top and see if there's anything to combine. There is not. Square root of 2, square root of 3, square root of 6. When I'm adding and subtracting, I can't combine any of that. So that is going to be, that nasty mess is going to be my denominator for the rest of this problem, which is fine. I can have that in the numerator. I can have that in the numerator, no problem. Now, 1 minus the square root of 4. The square root of 4 is 2. So 1 minus 2 is negative 1. And if you would like, you can certainly distribute this negative 1 into the top so that you don't have a fraction anymore for your final answer. But that is your final answer. You've got a nice, pretty real number, rational number in the bottom, and you've accomplished your goal. For number 7, same thing happens. Switch the sign on the second term to make your conjugate. I highly recommend parentheses. And then we'll do the same thing to the top, and we'll see what happens. Now this time the top, you don't have to FOIL the top, so that's kind of nice. You just have to distribute. So square root of 3 distributed to square root of 2 becomes square root of 6. Square root of 3 to the negative square root of 3 is minus the square root of 9. And then we have our fun activity on the bottom. So we've got first times first, outer times outer, inner times inner, and last times last. I will simplify where I can. So we know that these cancel. We know that the square root of 9 is 3, so I can make that the square root of 6 minus 3 on the top. Square root of 4 is 2, square root of 9 is 3, so now I've got a 2 minus 3 on the bottom, so that's negative 1. So I can make this negative square root of 6 plus 3 as my final answer. If you need to pause any of that and take your time on that, please do. Be meticulous as you're multiplying these things out. Number 8 is very similar. You guys know what the conjugates are, so I'm going to let you guys try that one on your own. There's your conjugate that you're going to use on both the top and the bottom. Take your time. You'll be 2 sets of foiling on that one. Number 9, you're going to be multiplying by square root of 5 minus 1 on the top and the bottom. You're going to be distributing on the top and foiling on the bottom, so I'll let you guys try that one. I want to make sure you know what's going on number 10 before I let you go off on your own. So number 10 has an interesting situation. You can do one of two things. You can either reduce this fraction first and then deal with the root problem, or you can try to deal with the root problem and reduce the fraction later. So either way is fine. You should get to the exact same spot. I think what I would like to do is reduce the fraction first. So I'm going to leave this radical here. And I'm going to say there's a 27 and an 81, and I can reduce that. If you need to do it in steps, let's do it in steps. Let's take a 3 out of the 27 and leave a 9, and take a 3 out of the 81 and leave a 27. Continue reducing. Leave a 3 here, and a 9 there. Continue reducing, a 1 over 3. So as long as you get down to the square root of 1 over 3, your reduction is fine. If you already knew that 27 divided by 81 is 1 over 3, that's fine too. But at some point, we need to get to this point where we have the square root of 1/3. And we can break that into the square root of 1 over the square root of 3. Square root of 1 is just 1 over the square root of 3. And so now we see our true problem. We've got this square root of 3 on the bottom that is a troublemaker. We can counteract that by multiplying by a square root of 3. So we'll be left with the square root of 3 over the square root of 9. And of course we know that the square root of 9 is 3. That's why we used it in the first place, because we knew that that was going to get us this pretty number. And we are left with the square root of 3 over 3 as our final. If you simply reduce this fraction and get to this point where you said, oh, I simplified, I'm down to something nice and pretty. It's prettier than the first thing I started with. This is still not proper. You cannot give me this as your final answer, 1 over the square root of 3. Okay, that's not going to work. Good job getting halfway there, but we need to continue. We cannot leave this radical in the denominator. We have to rationalize that denominator. Okay? So I think you should be on your way here. Certainly this guy is a little bit tricky. You know, we've got cube root of 54 over the cube root of 2. So use your skills to think of how you're going to get this guy up to a perfect cube. I'll let you guys try that one. Some of these you can simplify first and then try to rationalize the denominator, or you can try rationalizing the denominator and simplify later. Either one should get you where you need to go. Okay? And then 13 and 14 are more FOIL with the conjugates. Okay, so these are fantastic practices. I really encourage you to try these. They're all really, really good getting you prepared for rationalizing the denominator. Don't take any shortcuts. Try them all. Get that good practice in there so that it goes really quickly for quizzes and tests. And then just check your answers against the key.